welcome back to MGL, where we're going to now cover the Unit 305 Coldwater Systems Learner Outcome 1.2. So we've been working our way through, we've already done 1.1, now we're on 1.2. So remember, if you do find this video useful, please remember, drop a like, leave a comment, and even maybe hit that subscribe button and help support the channel. Right, by the end of this session, learners will be able to identify the various sources of water and the typical properties of water from those sources. Right, so there are two main categories when we talk about water sources within the UK. Remember we talked about in the previous video where we've got surface waters and all that, and we worked our way along for the percentages. Well, now we're just going into these in a little bit more detail. So we've got these things here. So we've got various surface waters that we have to worry about, e.g. lakes, reservoirs. Now, these are upland surface water. Why we say upland, though, is we usually use gravity to naturally let the water go to wherever it needs to go, but sometimes these are pumped as well. Then we have rivers. Rivers start at a high ground and often terminate at the sea. Remember with the water cycle where we get the evaporation, it goes up, it rains, it goes on, goes down the rivers, goes back to the sea. Nice and straightforward. And then the next one is canals. Not typically used for drinking water, but that water source is still there and could possibly be used if cleaned correctly. So it's more of a backup, but yeah, not really used. 2. Underground water sources such as a deep or shallow dug well. Now, wells draw water from below shallow impermeable strata. It's basically, we go as low as we can because there's 2 layers of water in most cases when it's on this one. The first layer is the shallow wells. This tends to not be clean water, so it does need some form of treatment. The better water is the confined aquifers below the impermeable strata, where it's gone through the filtration of all the soil layers and is now a lot safer. Okay, next one, natural springs. These again are just natural areas where the water will squeeze out of the watercourse and find a weak spot in the land, and this can be used as a water source. It's not very common around here in the UK. Borehole, man-made wells drilled directly below the ground water source. So we're going, instead of digging it down by hand trying to get a nice well, we're using the same technology that you use to drill a well for oil, but we're now using it to supply us water. So we drill the holes, we get to that confined aquifer, and we pump the water from there. Right, and then the last one is an artisan's well. Now, artisan's wells are still using the confined aquifer, but because there's like a dip in the land, water tries to find its natural level, so it will find a weakness somewhere in that ground and it'll bubble up, and that's where we get our water. There are some places I know around where I am in the Midlands where I can see lakes that will go up and down depending on how much rain we have or haven't had. So you could sort of tell how the water levels are doing underground. So that is an artisan's well. It's a natural occurring one where it bubbles up through the rock. Right, as I said before, in Unit 3.3, Scientific Principles, we've already discussed the effects of hard water and soft water further, but remember that water falls through different materials of the ground, which will affect their pH. So sandstone will produce soft water, moorland peat will produce very soft water. Now, the reason we have to know about these again is to make sure that we've got the right pipework for the right substance. So if they go through salts, they become permanently hard. And then if they go through limestone, they will get temporary hard. Now, the limestone one is the one that happens to be around where I am at the moment, the Midlands. So we have to deal with that a lot. But I have worked in areas where there's softer water. Now, you've got to remember, soft water is acidic. Hard water is basically as a sealant. It's lime scale. So you'll see scales in your kettle It will scale up your heating pipe works, things like that. So we've got to remember that from our sciences. The key thing to remember though is if it's soft water, we should be using plastic pipe, because the soft water is acidic and can damage the copper pipes. But if it is hard water, we can either use plastic or copper. Now, hardness of the water is important as it affects the pH. So let's have a look-see. Right, soft water, low minerals, is usually low in pH. Cameras are water, where are we going? With a pH of less than a 6.5 can be acidic, as I've already said, soft and corrosive. Now, one quick way of telling the difference whether you're using soft water at home or you've got hard water is when you wash your hands and you've washed the soap off and your hands still feel like they're soapy, that usually indicates that you've got soft water. If you feel rough hands afterwards, that's usually the harder water. Right, hard water, we have a higher pH. So water with a pH greater than 8.5 indicates that the water is hard. Water does not pose a health risk, but can lead to mineral deposits, as I say, lime scale. It's a very common problem we have in this area that I'm at. It can block up your heating system pipes work. It can get your taps go crusty, your showers, stops them from working. So it's important to remember what kind of water is where. So as I was saying, it depends where you are, depends on the kind of water that you're getting. In the UK, this tends to be our little map of go-to. So all the grey areas that you can see there on the map, so if I get my little pointer here, all these grey areas, that indicates that it is hard to very hard, 200 parts per million of lime scale, hard water. So very high chance that things are going to scale up. Then we've got our blues. So nice bits there. That I'm roughly, I think about there. So I'm sort of dancing on the edge between the two of them. To moderately hard of 200 to 200 parts per million of calcium carbonate. So it's still dangerous for our appliances. So we do burn out a lot of appliances in here. Then we've got this nice gold indicating the softer waters. And then that one is 0 to 100 parts per million. So as you can see, Scotland, Northern Ireland, lots of bits of Wales, Isle of Wight down there, Devon and Cornwall, all mainly soft water. So water falls on the moorlands becomes soft and acidic. Water that falls on limestone becomes hard and alkaline. Now, water is stored by companies, so we're talking like Severn Trent, Angular Water, all these kind of people, either in untreated state, in impound reservoirs and lakes, or as wholesome water in service reservoirs. So what that means is wholesome water means it's drinkable. So this water's already been treated and is stored in a proper clean reservoir. Whilst lakes and rivers and reservoirs that you could I think there's one near me, Napton Reservoir. It's a very popular fishing spot, hence the reason I know it. But it's also the supply of water for Severn Trent. But it's not clean because it's got everything in it. So they have to clean it afterwards. So water must be treated before it is put into the supply system. This is what the water companies promise us, is they're going to clean the water. Deep wells and boreholes, the quality of water is quite good due to the natural filtration process, which I said before, where the water permeates through all the stratas. Only requires sterilization treatment occasionally. Rivers, lakes and reservoirs, usually dirty and polluted. The treatment process usually involves water being strained, filtered, chemically treated and sterilised. So there's a long-winded process on that. That is the end of that one. So if you have any questions, please leave them in the comments below. When I get a chance, I'll answer them as soon as I can, or someone else might be answering it for you who has a better understanding. If you have enjoyed this and found the video helpful, please remember, drop a like, leave a comment, even hit that subscribe button and help support the channel. And yes, thank you for watching, and I will catch you in the next video. Bye-bye.